I hope you all are good and enjoying your time. Guys, today the topic what I'm going to discuss with you that is based on area between two curves. So this is a one part of the integral definite integration, and suppose we have a curve y is in term of y equal to f of x, and it is lying like this. Suppose the shape of the curve is like this. So I want to find the area of this curve with the line along x-axis, right? So what to do for the, because this is a case of a definite integral and we need some certain kind of limit. So if I will draw the projection of the one end of the curve along x-axis, similarly the second end along the x-axis, and suppose these endpoints along axes are A and B. So we are interested to find this shaded area and it will be calculated with the formula area of the shaded equal to integral as the along axis the limit ranges from A to B. So A to B, we will write y or f of x d of x, and because this is here we have y equal to f of x, the function whose curve has been plotted. Similarly, if we have another curve, say now y in term of g of x, like here g of x is this. Suppose this is origin. So then the area of this curve, that is y equal to g of x along the x-axis. Suppose this is point C and this is D, or you can say the same as A to B or C to D, it doesn't affect it. So we are interested to find this area. So the area of this shaded region, area of shaded now, for the function y equal to g of x will be formulated as integral of c to d g of x d of x, right? Okay. Similarly, now I want to find the area between these two curves. Like one is f of x and y other is g of x. Let's see the figure. The first curve was this. So this is y equal to f of x, and suppose we have the other one as y equal to g of x. Now we are interested to find the area lying between these two curves, right? Here, like this. We are interested to find the area between these two curves. So this can be formulated as area required shaded region will be, and first the we need to solve them simultaneously to get the point of limits. That's supposed to be P and Q. Suppose the limits along axis is lying between P and Q. So required shaded area will be, I can say, integral P to Q and then top top curves minus bottom curve and d of x. Here for this curve, what has been given here in figure, so I can write say suppose this is a part, this is not, no need, okay, the one case, two, and this is third case, we are discussing the third case, right? Say so the area of the shaded for this case 3 will be, what is the top limit is p to q, top region is function of f of x minus bottom is function of g of x and d of x. We have to use this case. Okay, this was a case study when the one curve or the two curves are lying along x-axis. We are taking the area along x-axis. Now what happened if they are in a way that we need to find the area along the y-axis? Now guys, we will see the stereo when the given curve, like this is force, say y equal to, now this time x is equal to f of y. So suppose the figure is like this, the curve is here, say and now we are interested to find the area of the curve with along the y-axis instead of x-axis. So for this y-axis we can make this little up. So this is y-axis and this is x-axis, and here is a, here it is b on y-axis. So we are interested to find the area of this shaded region, right? The curve, I'm making it little bold for you guys. This was the curve, right? Curve was x is equal to f of y. So here the area, the shaded area for this case will be integral the limits along y-axis a to b, here f of y d of y. And fifth one, suppose we have another x is equal to g of y. So and suppose the curve is like this, and we can keep the same limits a to b. Y-axis, x-axis. Here if we join this, you can see the shaded region becomes like this. Now the curve is x is equal to g of y, then area shaded for here for this case will be limit a to b integral of f, here g of y and d of y. The third case studies. Now suppose we are taking the final case, then when these two above curves, like you can see this and x-axis, and this is what y-axis, and we have two curves, like one was x is equal to f of y and other was x is equal to g of y. So they are the confined region between the two curves are this, and we are interested to find this area. and the limits you can say suppose a and b as well. Then here what to do, area required shaded will be definite integral ranging from a to b. Here you can say right function minus left function along y-axis d of y, or for this case here we can write it as a to b, right one is f of y minus g of y d of y. So these were the rules of formula what help us to evaluate the definite integral or the area between the y-axis and the curve, or axis and the curve, or between the two curves. Right now we use these rules to solve particular question. Okay guys, we are going to solve a particular question based on the area between the curve or line. Here, calculate the area of the region bounded by the line. Line is this, y equal to 8 minus 2x between the x-axis and the y-axis. As you can see this figure, we have a right angle triangle, so we can apply the basic rule of right angle triangle to how to find the area. That I can say the method one. There are two different methods for this question to be solved. Method one says area of a right angle triangle, that is we can say that shaded, half base into height. So here if you can see the base is goes to be 4 and height is what from the origin, that is 8. So 1 by 2 times 4 times 8, that 8 is 16 square unit. So that could be the answer with one method. but if we go with the basic concepts of definite integration what we have discussed before, then the area, as you can see here, the area, if you take this line along x-axis or y-axis, both will give you the right answer. So method 2. So area shaded will be along x-axis. What is the the range of the curve that's lying on the x-axis, that is 0 till 4. This is the range of what the line is crossing along axis from, is 0 till 4. So definite integral is 0 till 4 f of x d of x. Or you can apply along y-axis 0 till 8 f of y, and d of y. So both will give you the same answer. So you can apply in any one method. So here along x-axis, taking it 0 to 4, f of x is 8 minus 2x d of x. So by definition of integration, the rule what we apply here, we will get this thing. So 32 minus 16 minus 0 plus 0, that is 16 as well. So square unit, you will see the answer will remain same in either cases, right? So this is the area shaded. So any one of method. Similarly, you can apply along y-axis with the limits of integral, that's 0 till 8. So again you will get the same result. You can try by yourself. Okay guys, now in this question we have to find the area of the region bounded by the line y equal to x and the curve y equal to x square. So it's optional if we can draw the figure, the curve will y equal to x square will be like this from here to this is y equal to x square. And similarly, if you can draw the line y equal to x, so we will get this is y equal to x. Therefore, the shaded region will be this one between the curve and the line. And you can see here top we have the line and bottom we have curve. So we will see, as we have discussed, the area shaded will be A till B. Top is line, so first f of x minus g of x, those two functions, d of x along x-axis. So we need to get two values, as this is the point of origin, and we are interested to find what will be this to get the limits of the integral. So for this, as this time we have two different things, one is the line and one is curve. So for the limit we can solve them simultaneously. So we get x square equal to x by equating the two y's. So x square minus x equal to 0, 1x common, x minus 1 equal to 0. 1 is x is 0, or other point of intersection is x is equal to 1. So here it means this is what this question mark is equal to 1. So now it's a case, simple case. We need to apply in the formula written above 0 till 1 x, because the line is lying above top of the shaded region. So that is x minus x square d of x, and by simple integration x square by 2 minus x cube by 3, by applying the simple basic principle or the rule of integration, we get 1 by 2 minus 1 by 3 minus 0, that comes to be 1 by 6 units square. That is the required area. I hope it is clear. Okay guys, now for this question we have to find the area of the shaded region bounded by between the curves y equal to x square and y equal to x equal to y square. So we have two functions here, y equal to x square and this one. So first of all, we need to find the common or intersecting point of the curve to get the limits of the definite integral. So we can first draw it. It's better to draw it first. Roughly sketch is better. This is x-axis, this is y-axis. Y equal to x square will be this is y equal to x square, or we can write here y equal to x square, and the second curve is x is equal to y square, or yeah, or we can write this as y equal to plus minus square root x, but we will take the area, so positive root will be taken, better to write plus x. So if we draw the y equal to x square, it will, the curve will be like this. Here x is equal to y square, and this goes to be the shaded region between what we are looking for. One value seems to be 0, other we are interested to find what comes here. Okay, for the values we need to equate these two curves to find the intersecting point of the curves, which help us to take the limits of the definite integral. So we can say you have to solve this simultaneously. X square is equal to square root x because as we will take this x positive. One reason is that the intersecting point is lying above the x-axis, so we will take y positive here. If it is lying here somewhere, so then we can say that is taken as negative. But here we'll go with it. So we can say square on either side x4 is equal to x. So now, mm, for the limits at x is equal to 0, 0 power 4 is equal to 0. It means 0 is equal to 0. Left hand side equal to right hand side. So one of the limit is this true, right? Similarly, at x is equal to, we can say that is 1. So 1 power 4 is equal to 1. That is 1 equal to 1. So again your left hand side equal to right hand side. So again it's true. But if we take some other value, say 2, at x equal to 2, so it's 2 power 4 is equal to 2. It is not possible. So false. So it means the intersecting point are intersecting point along x-axis are 0 and 1. So these are the limits of definite integral. And above curve here is y equal to, here we can write y equal to square root x. As I told you, why we took the positive, because it's lying above x-axis. So area shaded, the required area will be the 0 to 1. Above is the second case, we can write it as above 1 square root x minus x square d of x. So let's see, it goes to be x power 3 by 2 times 2 by 3 minus x cube by 3, limit 0 till 1. It's 2 by 3 minus 1 by 3 goes to be a minus 0. It will be 1 by 3 square unit, right? That is the area of the required shaded region. I hope it is clear. Let's proceed to the next one. Okay guys, now we are going to solve the question that states calculate the area of the region bounded by the curve x is equal to 1 minus y square and x is equal to y square minus 1. And if we can plot this on a graph, you can see the curves are seem to be like this. X is equal to y square minus 1 is this, and the blue one is with minus y square plus 1. Okay. It is very much clear that when y is 0 along x-axis, the two curves will intersect at minus 1 and 1. Now, as we are interested to find the area bounded by these two curves, so for that we need definite limits of definite integral that's range from a to b, and this we can access by solving the two curves simultaneously. So if we equate it, 1 minus y square is equal to y square minus 1. So 2y square goes to be 2y square is equal to what can say 1. Y will be plus minus 1. So it means the range of these limits are minus 1 till 1. So rest is very much clear. Then the area, the shaded will be integral of minus 1 till 1, and right function is what? Minus y square plus 1 minus the left function is y square minus 1 and d of y. But simple solve with the by applying the simple rules of integration, or before that you can simplify if you want. Let's simplify first. Minus y square plus 1 minus y square plus 1 d of y, that will be minus 1 till 1 2 minus 2y square dy. Now you can apply the simple rules. We get 2y minus 2y 3 by 3, and the limits are minus 1 till 1. Upper limit 2 minus 2 by 3 minus lower limit minus 2 minus plus 2 by 3. It goes to be say 4 by 3 minus and minus 4 by 3. Once you simplify it, it becomes 4 plus 4 by 3, so 8 by 3 square unit is the required answer for this shaded area. I hope it is clear. Now guys, we are going to solve another question, that calculate the area of the region bounded by the curve y equal to x square minus 4x and the x-axis as shown in the figure. So it is very much clear the limits of definite integrals range from 0 till 4. So upper is x-axis and lower is y-axis. So we can say at x-axis y equal to 0. At x-axis we know y equal to 0, so we have rear area shaded equal to limits 0 till 4. One is function is this 0 minus other one is x square minus 4x d of x, upper minus in top minus bottom function. So it comes to be 0 till 4. We can write 4x positive minus x square d of x. Now we will integrate it. It becomes 4x square by 2 minus x cube by 3. So limit range 0 till 4, or we can say it's 2x square minus x cube by 3, 0 till 4. Upper limit 16 to the 32 minus 64 by 3 minus 0. So taking LCM, it is 96 minus 64 by 3 will give me 32 by 3, or 10 whole 2 by 3 square unit. That will be the required area for the given question. I hope it is clear. Okay guys, the concept has been discussed well, and now you can take your topical and try to solve the question based on the area of the region bounded by the curves, or curve and line, or line, or along x-axis, y-axis, and as we have discussed. Good luck. See you in the next video.